This is a bullet, and this is the target of the bullet. Now, if we draw a line between them, this will be the line of sight. And the path of the bullet is also towards the target like this at the start when it's shot. Now, let's imagine that the bullet moved from here to here. Now the new line of sight would be this, and the new path of the bullet would be a bit complicated because the bullet will try to track the target, and the bullet's tracking strength is not infinite. So if the bullet's tracking is 0, it will keep going at this direction and miss. If it's weak, it will try, but it wouldn't fully get there. If it's strong, then it will lock to the target and kill it. Now let's assume that it's a little weak. It will try to track it in the time it has moved, but it wouldn't be able to fully do that. And this angle right here is the tracking angle. So now, let's imagine that the bullet is really far away, and then it moves by the same distance at the same amount of time. This will be the new line of sight, and even if this bullet's tracking is weak, just like this one, it would be able to fully track it and lock onto it. Why? Because in a shooter game, the further a target is, the easier it is to track it with your cursor. You just need to move a little bit, even if it moves quickly. But if it moves at the same speed when close to you, you will have to adjust your cursor a lot. It's because the closer you are, the more you have to track. And this is the same principle. So the closer a bullet gets, the easier it is to throw away its tracking and make it go away from you. And now that we know this, we can move to the next step. When is a bullet considered a miss? Right, so this is the tracking angle. How much does it have to be a guaranteed miss? Well, 90 degrees. Why? Because look, there's the target. Bullet, and there's the target. Then it moves. Let's just ignore where it was in the past. Let's just draw it like this. So let's assume that this is the line of sight. It is the line of sight, we're not assuming. Let's assume that this is the path of the bullet. It's 90 degrees. The tracking angle is 90 degrees. And as you can guess, if the bullet is going like this, it will miss once it reaches 90, because it is no longer getting closer to the target. Which means our goal when dodging any bullet is to increase the tracking angle. It's not to just move away from it. And that is why we move sideways when we strafe a bullet. It's intuitive, but the math behind it can reveal a lot of stuff. So what's the most optimal movement to increase the tracking angle? It's simple. You just move in a perpendicular line to the line of sight. So this bullet would have to, or this target would have to move like this, perpendicular to this line. Now imagine if the target is moving like this, perpendicular to this line. Then we are not really increasing this angle, we're just giving a chance for the bullet to adjust its tracking. This is why moving in a perpendicular line would increase the tracking angle more, a perpendicular line to the line of sight. So let's apply this to Dark Souls. Freda's side drag is really hard to strafe, so for the longest time we thought it's RNG, but she's literally just a bullet. And luckily enough, there is a way to move perpendicular to her line of sight. Lock on.